So I have drawn the diagram which is given to us in the problem. It has been stated that we have to go from S to T. The available routes are from SAT, SBAT, SBCT, SDCT and SDT. Okay, and the cost of fuel is given to us. So for example, the cost from S to A to T will require 9 rupees plus 5 rupees plus the toll at A. Okay. Now in the first problem, the government wants to ensure that the travelling cost for any of the routes available should be the same, and it has also been stated that the route from B to C is closed. Okay. So now the available options are SAT, then SBAT, then SDCT and SDT. Okay. Now the fuel cost required for SAT is 9 plus 5, that is 14. SBAT will be 2 plus 2, 4 plus 5, 9. For SDCT it will be 10, and for SDT it will be 13. Now we'll have to adjust the toll which we collect at A, B, C and D such that the total cost for each of the routes is going to be constant. So here we only have one option A, here we have two, B and A, here we have D and C, and here we have D. Okay, now if we want to make sure that all the costs are equal, I'll take the highest cost available. For example, in this case it is 14. So I'll make sure that the cost of A is minimum. So I'll keep it as 0. So here it will be 0. Now from SBAT, right now we just need 9 rupees to travel. So I'll have to make this toll as 5 rupees. So in this case it is 14. Now this becomes 14. Now here we have two unknowns, D and C. So I'll skip this one. I'll go to SDT. For this the cost is 13 rupees. So the toll at D has to be 1 rupee. So this will be 14. And this will be 1 here. So this will have to be 3. So this cost will become 14. Now we can see that the cost for travelling from S to T via any of the following routes is going to be 14 rupees. So the answer will be A is 0, B is 5, C is 3, sorry this is 5, and D is 1. Okay, the only thing different in this problem is that the route from B to C is now working. So we have the options SAT, SBAT, then we have SBCT, SDCT and SDT. Again, just like the last video or last problem, we have this cost as 14, this as 9, in SBCT we have 7, SDCT will be 10 and this will be 13. Here we have a toll booth A, here we have both B and A. Then we have B and C, D and C and D. Okay. Now I'll keep the toll at A as 0. So this will be 0. And in order to make this as 14, I'll have to keep the toll of B as 5. So this is 14, this is 14 now. If B is 5, this will become 12. So C will have to be 2. So again this is 14. If C is 2, then D will have to be 2. So this will again be 14. But in this case, the cost is already 13. When I keep the toll of D as 2, this will become 15. So our objective fails. For this, what I'll do is, this is 15, so I'll keep this as 15. I'll change the toll at A from 0 to 1, so this will become 15. Now this will again become 1 and this will change to 15. In this case, the cost of B cannot be changed, obviously, because we have fixed the cost here. So I'll change the cost of C, or the toll at C, sorry, from 2 to 3, and this will become 15. When I change this, this becomes 15. So now the objective is satisfied, that all the costs are going to be same in each case. So our option will be A is 1, B is 5, C is 3, D is 2. 1, 5, 3 and 2. So in this problem, it has been given that we have to ensure that there is no traffic flowing from D to T. So for this, if you look at the previous question, I had made all these costs as 14, but the cost of SDT came out to be 15 in spite of that, and I kept A as 0 and C as 2. So if I change these values, now this is going to be 14. Rather, all of them are going to be 14 except for SDT. So our answer has to be 0, 5, 2 and 2. Okay, so in this problem, we have to ensure that the cost of traveling from any of the routes has to be the same. If you look at question number 2, which has been discussed already, and this question, they are technically the same question. So the answer is also going to be same, which is 1, 5, 3 and 2. Okay, there are two parts in this problem. The first part, it is given that the cost of traveling from S to T should be minimum, and the second condition is given that less than 70% of the traffic should pass through junction B. Okay. Now we have the options given here. We'll go in ascending order since we need to find the minimum cost required. Let us start with option A, rupees 7. If we choose this option, we have just one route available, which is S, B, C and T. Okay. But in that case, 100% of the traffic will have to pass through junction B. So the second condition is not met. So this is wrong. For option B, there is one route S, B, C, T and another route S, B, A, T available. Okay. Now S, B, A, T, already the cost is going to be 9 rupees. This means at junction B, I'll have to have a toll of 0 rupees, and at C, it will be 2 rupees. Okay. Now, all the traffic will have to pass through B for routes SBCT and SBET. So again, 100% of the traffic is going to pass through junction B. So again, this is wrong. Let's go to option C. Again, in case of option C, if I try to use these two routes, SBCT or SBAT, I'll have to use junction B in both. So 100% of the traffic will again pass through B. Now instead of that, what I'll do is, I'll use SBCT as one route and SBCT as the other route. This means the cost at SBCT is already rupees 10. So at junction C, the toll is 0. So at junction B, I'll have to collect a toll of rupees 3. Now 50% of the traffic passes through junction B and 50% passes through junction D. So our answer is going to be option C, 10 rupees.